We are the ForensX computer science team comprised of current juniors and seniors enrolled at the Jefferson County International Baccalaureate School in Irondale, Alabama. We are competing in the 6th Congressional District under Representative Gary Palmer. Our app, titled the Famine Risk Index Early Detection System, visualizes at-risk populations from famine by mapping the relationship between drought and populations at risk via an interactive user interface with a focus on ease of use. Our motivation for this project lies in humanitarian aid. We look to identify specific populations that are at risk from famine by studying the consequences of drought on famine and help get aid to those who need it. We do this by formulating and visualizing our custom risk model, FRI, the Famine Risk Index. The problem that we look to solve is twofold. First, the UN publishes its Global Hunger Index, or GHI, which takes into account undernourishment statistics, child wasting, child stunting, and child mortality. However, the GHI neglects environmental hazards. Additionally, data sources that the UN use are withheld and are limited. The second problem is that no model adequately incorporates environmental hazards with identifying at-risk populations, specifically from famine. Our solution provides an intuitive and interactive visualization for identifying at-risk populations, allowing users to identify these populations through our FRI model. Our Famine Risk Index considers rainfall, vegetation abundance, and population density of local areas, as shown on the screen here. Our FRI leverages demographic data, climatological data, and NASA satellite data in order to calculate the relative future risk of famine in a location. This data was obtained through querying data from 3 NASA satellites and ground-based observations as well as 1 TAMSAT resource. Our Famine Risk Index highlights significant anomalies within the dataset as high-risk areas for famine. Here you can see our app. Our index is displayed on a progressive color scale which allows scientists and researchers to easily identify the variation of famine across regions. A darker color represents a higher FRI value, which are populations that are at a very high risk of famine. By using our extensive filters, researchers can refine their search. For example, researchers can use the radius slider to aggregate per population sizes, specify percentiles to only visualize specific populations, and also change height overlays to visualize other environmental factors such as rainfall, soil moisture, and vegetation.